Hey guys, so today I'll be showing you how to quickly configure mesh using the ezMaster. If you want information on how to install the ezMaster, you can check on our previous video. To be able to configure mesh on the ezMaster, just be sure that you're running the latest version. So after logging in, you can either create a new project or work on the existing one. I'll be using the EWS330AP, which is a Wave 2 2x2 access point. Other models that are compatible for mesh are any EWS device so long as they're running AC. Here's a quick list on all the compatible models that can run mesh. Let me add this APs to my device list. While waiting for that, you can go ahead and set up your mesh profile. So for the ezMaster, you can set up multiple mesh profiles depending on how many you need. But if you're using the controller switch for managing your access point, you're stuck with one profile. So here you can set up any mesh profile name that you want. You can add a description. For the mesh band, for most of the deployments, we'd suggest to use 5 GHz because it's more stable in terms of interference, and you have bigger bandwidth on the 5 GHz radio. For the mesh ID, you have to key in at least 8 digits. The password is at least 8 characters. Okay, so the mesh RSSI here is your threshold in dBm. By default, it's set to -80. So that means that if the signal quality between two of my access points drop to -81, the mesh link would be broken. So after configuring your mesh profile, you can go ahead and set up your AP groups. All the mesh APs that you want to link together should be in one group. So go ahead and go to wireless settings. From here, select your country. So this will reflect what channels are available for your network. For the channel width, I'll be using 80 MHz to have the full AC bandwidth. Currently for mesh, you have to set a fixed channel. In the future, we'll be having an update so that you can just set it to auto and let the system use the best channel based on your environment. So for this demo, I'll be using the lowest power possible, but this would all depend on the environment where you're going to deploy your access points. Okay, so here I'm not really going to use my 2.4 GHz SSID, so let me disable that. I'll just configure my 5 GHz SSID instead. So some people get confused when it comes to mesh. They would think that mesh is similar to a repeater. In a way, it's similar, wherein you can extend the range of your existing setup. But one major difference is, as you can see from here, I can still freely configure my access point. So that means that if, let's say, I have mesh point A and then I have mesh point B, my SSIDs for both mesh APs can be different or independent from each other. After that, head on to your advanced settings. Scroll down to the very bottom and you should see the mesh setting there. Enable the option and select your mesh profile. If you have multiple mesh profiles, you can select the correct one from the list. Finally, don't forget to add the APs that you want to be part of this mesh group. So I'll be adding 2 of my EWS330 APs. Okay, so it will be applying the settings for your group, so just wait for it to apply. Once your devices are online, you can go ahead and verify your mesh connection. So from device management, go to mesh, go to node list, and then select your mesh profile. From here, you can see the status of your mesh APs. So root node means the device is wired on your network. If it's just linked through another access point via mesh, it will show as a mesh node. From your mesh settings, you can test the ping, you can do traceroute, you can do a throughput test to check the speed between your mesh nodes. Let me run one right now. So from here, you can quickly troubleshoot or check the status of your mesh connections. Under visualization, you also have an option here for your mesh view. Here you can see how all your mesh devices are interconnected to each other. Let's say you have 3, 4, or 5 mesh APs in one group. You can see which AP goes to where, etc. So now let me unplug one of my access points here and just power it up using a power adapter. I'll be separating this AP from the network. It's important to remember that for the initial configuration, all your access points must be wired when setting up mesh. Once you have done the setup, then you can unplug the mesh APs. Going back to mesh settings, you can see all your offline mesh nodes from the isolated node list. Since I have unplugged the other AP, right now you can see it's isolated. that means that it's currently offline or out of reach from your mesh coverage. Okay, now that our AP is back online, let's go back to the mesh settings, check the node list. As you can see, one of the APs have already changed its status. From root node, now it's showing as a mesh node. It will also display how many hops the AP is from the root node. And on mesh view, this would be reflected as well. So you have your root node here, and this is your mesh node. We have several recommendations when it comes to mesh. Our suggestions are, for every one root node on your network, meaning the wired access point, we recommend to have a total of 7 mesh nodes connecting to it. You can have more than that in actual, like for example, let's say you have 10 APs or 20 APs with only one root node amongst them. It will still work, it will still connect, but your throughput would be very slow, because imagine you only have one AP supplying access to the rest of the mesh nodes. So that one AP that's wired will be the bottleneck of your network. So in order to have a better connection, you need to have more root nodes. The maximum number of hops that we recommend are 3. So if you're looking at a linear topology from the root node and then you have 3 hops, this is our recommended number of hops. Again, you can have more than that, but the bandwidth and throughput may be low and your latency can increase. So currently in one mesh cluster, or for every mesh profile or mesh group, you can have a total of 32 mesh nodes. Of course, if you have that number of mesh nodes interlinked with each other, we recommend to have at least 4 of them that's wired to have the best performance possible. Also, the more wired nodes that you have, or the more root nodes that you have on your network, the better your network structure is when it comes to failovers. So let's say one of your root node goes out, at least there are still other root nodes available on the network to get the data. So there you have it. Thank you for watching.